Hello guys, I just want to do a clarification in this problem that we did. We were doing this member and I already posted the corrected solution for that. Please go and check it, but when I was teaching the class, I was going so fast and I omitted a step here. So when you do the shear diagram, which is this part, of course you start with this one, which is 13.15, and then you go in the direction of the load and you end here in 66.85, and this is gonna push it up to 0, and that's correct. Yeah, given this positive and negative, when you want to build the moment diagram, you need to find this distance here. You have several ways of finding that distance. You can do, for example, you can call this x, and if this is x, this other distance is going to be 8.94 minus x. And then you relate these two triangles, and you can say, okay, x is as 13.15 as 8.94 minus x is at 66.85. When you do that, you just pass this here, pass this there. Okay, 66.85x equals 8.94 times 13.15 minus 13.15x, and then group all the x together, and then you get 66.5 plus 13.5, 66.85 plus 13.15, that's 80. So 80x equals the multiplication of these two, and it's 120.69, and you solve for x, which is 1.5. 1.5. Oh, I made an error again. I put this value here, I multiply this one by 13.5. This is not 120. This is 8.94 times 13.15. This is 117.56, and when you divide 117.56 by 80, you get 1.47. So 1.47 meter. That would be one way that you can calculate that distance. And of course, this one is going to be 8.94 minus x. There's another way that you can do that, and you could start with this shape, 13.15, 66.85, and the total length is 8.94, and then it's like I draw like a parallel line to this one. Of course, if this line is parallel, this distance here will be 13.15, as well as this one 13.15, and this total will be 80 then. And then I compare this little triangle with this. Let me get this thing here. Where this big triangle right there, and if you do that, then you can say, if you call this x, you can say that x divided by 13.15 is going to be equal to the total 894 divided by this, which is 80, and then you solve for x, and then you say that x is equal to, well, 8.94 times 13.15 divided by 80, and it's 1.47. And the third way, which is the one that I was saying, is just an application, a direct application of this one here. That's it. So you can convert this into the formula, if you will, and that will be x equal this height of this triangle, 13.15, multiplied or divided by 80, and if you realize 80 is the summation of these two, but at the same time is the total load here. So you can divide by the total load and multiply that by the length of this, because this A94 is this length. And then you get x equal 1.47. Similarly, if you want to calculate, let's say, this distance here, in this end, you could say that that distance, I don't know, I'm going to call it x2. That distance x2 will be the height of this triangle, 66.85. Same situation, the height of the triangle, divided by the total load, which is 80, and multiply that by the length, which is 8.94. And if you do that, then you have 66.85 divided by 80 multiplied by 8.94, and that is 7.47. 7.47. That 7.47 will be this one, and the 1.47 will be that one. And if you add both of them, you're gonna get the total length. Now, summarizing that, if you have these type of situations and you want to find the intersection of the line, what is this distance x? And you know this is h1 and this is h2, and the length is L. What you have to do is say that x is equal to h1 divided by h1 plus h2 multiplied by the length. I hope this clarification makes the video or makes the problem easier or more clear. I apologize for that error. I was rushing through that part, but now you have a better understanding, hopefully, of what is happening here. See you in the next lecture, guys. Thank you.